This is task 6, question 3 from the Digital Electronics course notes. This is another example of a logic circuit where we have 3 gates to consider, and we have to work out the expressions coming out of the gates on the left-hand side of the diagram before we can work out the expression for Z. In this particular case, we could deal with the OR gate or the NOT gate first, because neither one is dependent on the other one. The outputs both feed into the AND gate. But for the sake of starting with the lower letters in the alphabet, we'll look at the OR gate first. I've highlighted in red which gate we're talking about here. This is a symbol for an OR gate. And our table on the left tells us that when we have 2 inputs going into an OR gate, we represent them by putting a plus between them. So the output of this OR gate is A plus B. We can then turn our attention to the NOT gate that's fed by input C. And what our table tells us, whatever input we have to a NOT gate, the output is represented by that input, a bar across the top of it. So C bar is our output from the NOT gate. Then we combine these two as inputs to the AND gate. An AND gate tells us that we take our 2 inputs and place a dot between them. So we have A plus B as an input, and we have C bar as an input as well. We have to be careful when we have A plus B, because we want to make it clear that it's A plus B that's combined with C and not A plus B dot C. So we put brackets around an input whenever it's got a plus in it to make sure that we're clear that C is combining with A and B combined and not B separately. And with all those symbols put in, this gives us the Boolean expression Z is equal to brackets A plus B dot C bar as the representation of how this logic circuit can be expressed in Boolean algebra.